And chapter 4 is about the smart manufacturing. 5G has a now formed organization called 5G ACIA. This will push the automation of intelligent manufacturing and automation. And this 5G can be used in the intelligent manufacturing in such ways, like the machine-to-machine control. Machine-to-machine control. This is very typical URLLC. Okay. Need low latency and reliable. And the signal should be very reliable. Okay. AGV. Okay. This is for positioning and transportation. This is for the logistics. Okay. Automated logistics. These are URLLC. And for this is a real-time operation guide, AR. Okay. AR. And machine vision. Okay. Vision. Right. These two is related to video, EMBB. Okay. EMBB. And then for forecast maintenance, device maintenance, we need a lot of sensors to monitor the status of the devices and preventative maintenance. A lot of sensors in the MMTC, massive amount of machine type communication. So different scenarios. Okay, for communication, 5G can provide all of these, right? Okay. These 3 types, and the manufacturing of 5G in 5G will take a bigger role. We have the communication for the industrial in the year of 2017. Only 6% is realized by wireless. Others are just by wired, by cables. Okay. And the year predicted to the year of 2022, the wireless connection will reach 20%. And then to the year of 2026, this will reach around 58%. This will more than the fixed line connection. This is a development trend. This is wired and wireless. Wireless will become more and more proportion in the future for the communication in the industry. And for the industry manufacturing, we will take a very big proportion for the economic activities. We have seen this picture already, right? And here we have one example for the intelligent manufacturing, which is a BOSCH future factory. The BOSCH future factory, they want to replace all the labor with the machines. Now they have around 90% of OEE. OEE means overall equipment efficiency. 90% is automated. In the future, they want it to be 100% automated. Using 5G. Okay, 5G can satisfy their requirement. Okay. You can see here is their network structure. They have their terminals. Okay, these terminals may be some robot, or maybe need some control, maybe human being for AR, VR. Okay, maybe for some sensors. Just some terminals needed for the communication. They need different type of communication. Some they need broadband. Okay. EMBB. Some they need massive connection sensors. Some they need reliable connections. Okay. Through the radio network, and if they need low latency, some applications need to be in the edge computing, and some other communication may need go to their service center, okay, through the core network, transmission network. So their network structure like this. And the services, main types are motion control, safety traffic. This is a very typical scenario for the URLLC. They need very small latency, okay, and they need a very high reliability. And for condition monitoring, for some sensors like this, condition monitoring, MTC scenario, they do not need a very high requirement of the latency or the reliability, but they need massive connections. And for some video augmented reality, this type, AR. they need megabit or gigabit level of throughput. So these are the scenarios needed. So we can say that the 5G can satisfy this requirement. For 4G or 3G cannot satisfy the requirement. Okay, so this is about example for the future factory of BOSCH.